Hi, this is Maggie. In this video we'll talk about a data type that allows you to store a collection of values together under one name. This data type is called a list. To demonstrate the syntax of lists, I'll define a list here in the console and access some of the values. I define a list variable the same way I define any variable, by placing the variable name on the left side of an assignment statement. I'll define a list called numbers. So numbers equals, and then on the right side I write an open square bracket. Now if I put a close square bracket, I have an empty list. If I want to have some values in the list, I put them between the brackets, delimited by commas. I'll put some integers in there, 1, 2, 3, 4, 5. I can put any type of data in a list, so these values can be integers as I have here, or floats or strings or booleans or other lists. They could be data types we haven't really worked with yet, such as tuples or dictionaries. Okay, so there I have a list, and if I ask Python to evaluate the value of numbers, it gives me the list of values in brackets. What's the point of this? Well, it's very useful to be able to store a collection of data. Imagine we need to store a collection of names, addresses, the number of minutes logged by children in a reading program, volunteer hours worked, coordinates of shapes on a screen. It's an amazingly useful construct. So now that we have our list, and we can see that the list name evaluates to the entire list, how do we get at those individual data elements? This image, which is figure 2.2 in your text, shows a list of strings and their indices. Lists are always indexed like this, so that you can access each element in the list by using the list name sub-index. So, for example, if I write numbers sub-0, which is numbers open bracket 0 close bracket, and I press enter to ask idle to evaluate that, I get 1. 0 is the index of element 1 in our list numbers. We have 5 elements in our list with indices 0 through 4. A very common kind of error in list processing is an off by 1 error, where you try to index past the end of the list. If you remember that the last index into the list is always 1 less than the number of elements in the list, and that list indexing always begins at 0, you have a start at avoiding an off by 1 error. Now we can also assign into the locations in the list, as lists are mutable, which means changeable. So I can put numbers sub-0 on the left side of an assignment statement, and let's assign in the value 10. And then ask Python to evaluate the list numbers, and you can see that it's now 10, 2, 3, 4, 5. Okay, so we can define them, we can access individual elements, and we can change individual elements. Let's talk a little about the implementation of lists, and in fact all variables in Python. This image, which is figure 2.3 from your text, is a representation of the 2 different kinds of memory that are generally present in a program. There is stack memory, which is where your variables and parameters are stored along with some administrative information. Every time the flow control enters a new function, a frame is put on the call stack containing the variables defined in that function's namespace. But the actual values for the variables are not stored on the frame in the call stack. Each variable on the call stack is a reference to a location in the heap, which is a more dynamic memory area. The actual values are stored in the heap. This might not seem important right now, but it will become important in understanding how lists are copied and passed as parameters to functions, so keep this representation in mind. Lists are objects, which means there are operations that we can do to lists by using the dot notation followed by the operation defined on the list. Object operations or functions are called methods. An example is append, which adds an element to the end of the list. So to review, our list contains the values 10, 2, 3, 4, 5. If I write numbers.append and then pass a value in parentheses to the append method, that value will get added to the end of the list. Let's write numbers.append1 and press enter. And if I now ask idle to evaluate numbers, you can see that it's 10, 2, 3, 4, 5, 1. If we want to add a value at a particular location in the list, we can use the insert method. The insert method takes two arguments, a value and an index where we want the value to be. The index is the first argument and the value is the second. Suppose we want to put the number 15 between the 10 and the 2. The 10 is at index 0, so we would be putting the 15 at index 1. Numbers.insert 1, 15. We'll put the 15 at index 1 and move everything from index 1 and up one index to the right. So the value 2 is at index 2, the value 3 is at index 3, etc. Similarly, we can remove an item from the list by using the remove method. Numbers.remove 15 will remove the 15. You can see when I evaluate numbers, the 15 is no longer there. Now, remove will throw an error if I try to remove an item that isn't in the list. If I try to remove 15 again, Python will throw an error. We can use in to test if a value is in a list before removing to prevent that error. So I can write if 15 in numbers, numbers.remove 15. And you can see no error is thrown because the remove code never executes. 15 in numbers evaluates to false. We'll look at one final method, which is the copy method. First, I'm going to show you something that doesn't necessarily work the way you might think. I'm going to write numbers2 equals numbers. That's an assignment statement, and the right side of the assignment statement evaluates to numbers, and that is copied to numbers2. If I ask idle to evaluate numbers2, it looks like a copy of the list numbers. But it's not. It's a copy of the reference to the list numbers. You might remember our representation of memory, where we have the variable on the stack that is a reference to the actual data in memory. What's copied in the assignment statement is the reference. So I end up with two references to the same list. I can demonstrate this by appending a value to numbers2. I'll write numbers2.append 100. Now I evaluate my original list, numbers, and it has the value appended. So I didn't make a copy of the list in the heap, I made a copy of the reference to the list on the stack, and now I have two variables referencing the same list. You might want that, but you might want to copy the whole data structure so you can keep the original list but do something with the copy. So the way to get a copy of the list is to use the copy method. Numbers2 equals numbers.copy. Okay, now I'll append 200 to numbers2. And when I evaluate it, you can see it's the original list, numbers, but with 200 appended. But when I look at numbers, it isn't changed because I copied the whole data structure in memory, giving me a whole new list when I used the copy method. Now there's one other way I can copy a list or part of a list, and that's using list slicing. List slicing allows us to specify the part of a list using indices that we would like copied into a new list. If, for example, I want the first two elements of numbers, or the elements at index 0 and index 1 to be precise, and I'm going to store them in a new list called numbers slice. I write numbers slice equals numbers, open square bracket, just like I'm indexing, 0:2, close square bracket. Now if we look at numbers slice, we can see it's the values from index 0 and index 1. Notice that I put index 0 first and index 2 second. The way slicing works, we specify the starting index and then one past the ending index. You might think of this as up to but not including. So we want the elements from index 0 up to but not including the element at index 2. I can specify the first index, the second index, both indices, or neither index. If I omit one or both indices, the default indices are used. The default indices are 0 and the length of the list. So if I want from index 2 through the end of the list, I can write numbers 2 : close bracket. If I want from the start of the list through index 2, I can write numbers 3 : close bracket. If I want the whole list, I can write numbers, open bracket, close bracket. That is some of the syntax of working with lists. Practice creating lists and then predicting the outcome of indexing, slicing, and append, insert, and remove operations. Once you can predict with perfect accuracy, you're ready to move on.